Hello guys, welcome to your channel Learning Point. Today we are going to study implicit functions exercise 3.4, which is a part of your new syllabus of the 12th commerce, which is prescribed by the government for the year 2020-21. In the previous lecture I had given the definition and a small part, some examples of the implicit functions. Now today we are going to study exercise 3.4. So question number 1 says find dy by dx as usual. Under that, the first one is root x plus root y is equal to root a. In order to find the derivative, we will say differentiating with respect to x. So derivative of root x is 1 upon 2 root x. When we want to find the derivative of root y, we will express this as root of fx, and the derivative of root fx is 1 upon 2 root fx multiplied by derivative of fx. In the video of composite functions, I had told you that anything other than x is always considered as fx. Therefore, I consider this y as fx. So I get 1 upon 2 root fx, which is 1 upon 2 root y, multiplied by derivative of fx, which is dy by dx. And root a is a constant, so the derivative of the constant is 0. So I get 0 on the right hand side. Now what I do over here is I transfer this element on the opposite side, so it becomes minus. So we get over here 1 upon 2 root y dy by dx is equal to minus 1 upon 2 root x. This 2 and 2 gets cancelled off. Cross multiply the root y on the opposite side. So we get dy by dx is equal to minus root y upon root x. So guys, that is our required answer for the sum number 1. Let us see the question number 2. Question number 2 says x cube plus y cube plus 4x cube y is equal to 0. So now in this particular question, again when we want to find dy by dx, we differentiate this with respect to x. When we differentiate with respect to x, derivative of x cube is 3x raised to 3 minus 1, which is 3x square. Y cube over here is considered as fx raised to n. Fx raised to n, the answer is n into fx to the power n minus 1 multiplied by derivative of fx, and because anything other than x is always fx, therefore y is also fx. So what I do over here is I consider 3 into y raised to 3 minus 1 multiplied by derivative of y, that is dy by dx, plus for the second term, in fact the third term, which is 4x cube into y. There are two terms. I consider 4x cube as one term and y as another term, and treat them as a product of u and v, two functions. So if the product is available, then in such a case we will have to apply the multiplication rule. The multiplication rule is if y is equal to u into v, then in such a case dy by dx is v du by dx plus u dv by dx. So in that case I will get over here y into derivative of 4x cube plus 4x cube into derivative of y, and that is equal to 0. Now these terms will come down as it is, 3x square plus 3y square dy by dx plus y multiplied by 4 is the coefficient, so we leave it as it is. Derivative of x cube, as we did in the beginning, it is again 3x square plus 4x cube dy by dx is equal to 0. Now what we do is we take out dy by dx common from these both terms, and the terms which are independent of dy by dx are taken on the opposite side with the change of their sign. So I get over here therefore dy by dx into 3y square plus 4x cube, and this will become minus 3x square minus 4y multiplied by 3x square. So to find the value of dy by dx, what we do over here is we take out minus 3x square common from these both terms. So in the bracket I will get 1 plus 4y, and this element on the left hand side will be divided on the right hand side so that I get my final answer. This is equal to 3y square plus 4x cube. So guys, that is our final answer. Okay, we have a similar question, sum number 3. The question is x cube plus x square y plus xy square plus y cube is equal to 81. Now when we want to find the derivative of this function, we will once again say differentiating with respect to x. So the derivative of x cube is equal to 3x square, and derivative of y cube, that is going to be equal to, as we did in the previous term, 3y square dy by dx. Derivative of the constant term is 0, so we write this 0. Now what about the two middle terms over here? In the two middle terms, I can see x square into y, they both are multiplied, so I will apply multiplication rule. Once again, x and y square are also multiplied, so again we will apply the multiplication rule in these two terms. So for the first two terms, if I apply multiplication rule, that becomes v derivative of u, so y into derivative of x square, which is y into 2x plus x square into derivative of y, so it is just x square divided by dx, plus for the next term again y square into derivative of x, so it is y square into y, plus x into derivative of y square, so it is x into 2y into dy by dx. Now what we have to do over here is I have to take dy by dx common from all these terms which are having dy by dx, and the terms which are independent of dy by dx will transfer to the opposite side with the change in their sign. Therefore, in the next step, I get over here dy by dx as a common term. The first term over here is x square plus 2xy plus 3y square. Then on the right hand side it is minus 3x square minus 2xy and minus y square. Now just what we have to do over here is dy by dx. Take out all the next terms minus common and rearrange them. So y square plus 2xy plus 3x square divided by, and in the denominator I get over here it as minus of x square plus 2xy plus 3y square. This minus won't come over here, it will be just the denominator as it is. So that is your answer for the sum number. Let us see the question number 2. Again in question number 2, it is asking us to find dy by dx. So let us see the first question that he has given to us. The first question says y into e raised to x plus x into e raised to y. Is equal to. Now in this term, if you guys observe very carefully, there are two terms which are multiplied, so this becomes your u and v. Again here also this x is u and e raised to y is v. So because I want to find the derivative, I have to write over here differentiate with respect to x. So it is v, that is e raised to x into derivative of y. So e raised to x dy by dx plus y into derivative of e raised to x, which is e raised to x, plus for the next term again e raised to y into derivative of x, which is 1, plus x into e raised to y derivative of e raised to y, which is e raised to y into dy by dx. How do we get this? I consider e raised to y as e raised to fx. So the answer for e raised to fx is e raised to fx into derivative of fx. As I told you in the beginning, anything other than x is always fx. Therefore here also y is same as fx. And derivative of the last term, which is 1, which is a constant, the answer is 0. So I get over here the terms which are having dy by dx, first and the last term, and the middle two terms, they will be taken on the opposite side with the change of their sign. So in such a case, I get dy by dx as a common value, and in the brackets e raised to x plus x e raised to y is equal to minus e raised to y minus y e raised to x. So guys, in order to get our final answer, we take out minus common from these both terms, e raised to y plus y e raised to x, and over here we divide the left hand side element e raised to x plus x e raised to y. So guys, that is our final answer for dy by dx. Isn't that very simple, guys? Let us see the question number 2. Again, question number 2 says x raised to y is equal to e raised to x minus y. Now guys, if you observe carefully, this is in the form of variable raised to variable. And when we come across this format of variable raised to variable, the easiest idea to solve this is to take log on both sides. So when we take log on both sides, left hand side over here will become log of x raised to y. Right hand side will become log of e to the power x minus y. Now with the help of property of log, I can take this y behind the log. It is y log x. And here it is x minus y into log e. What is the property? The property of log is log of m raised to n is equal to n into log of m. Now, in case of logarithm, the log of base of this log is e in case of calculus. So we have a property of log according to which I can say that log of any number to the same base is 1. Therefore, this element will become equal to 1. So on the right hand side, when I write my next step, I will just get y into log x is equal to x minus y. Now transfer this y on the opposite side, so it will get added. So I will get y log x plus y is equal to x. Now take out that y common from there. So it is log x plus 1 is equal to x. And now what we can do is we can write over here y is equal to x upon log x plus 1. So now any further simplification is not possible, guys. So now we will say differentiate with respect to x. So when you differentiate this with respect to x, you will get dy by dx is equal to, okay, before directly solving, let me give you the rule. We are going to solve it by using u upon v rule, which is v derivative of u minus u derivative of v divided by v square. So over here I consider that log x plus 1 is equal to v and x itself is u. So log x plus 1 into derivative of x, which is equal to 1, minus x into derivative of log x plus 1, which is 1 by x plus 0, and whole upon v square. So this is log x plus 1 the whole square. Now this positive and negative x will get cancelled on opening the brackets. So I will get over here log x plus 1 minus 1 upon log x plus 1 the whole square. We cancel off the positive and negative one, as I told you, to get my final answer, which is dy by dx, which is equal to log x upon log x plus 1 the whole square. So guys, that is our final answer. Yes. Now let us see the sub number 3 of question number 2 guys. Sum number 3 says x into y is equal to log of x into y. Yes. So on the left hand side you are having just x into y, which can be differentiated by using the multiplication rule. On the right hand side, if I have it as log of x into y, I can use the multiplication rule over here after taking the log of fx. Otherwise, if we want, I can also use the property of log, according to which this can be also written as x into y is equal to log x plus log y. I would personally suggest to go with this method for the simple reason that why should we need to apply multiplication rule for 2 times when we are having a simple property of log to simplify this? So better we will directly apply the property of log. Now on the left hand side we have got no option but to consider x as u and y over there as v and differentiate this with respect to x. V into derivative of u, so it is y into derivative of x, which is 1, plus u into derivative of v, so it is x into derivative of y, which is dy by dx. On the right hand side I get log x, derivative is 1 by x, and derivative of log y is 1 by y dy by dx. Obviously when we are finding the derivative, we will write over here differentiating with respect to x. Now what I will do over here is I will take these both terms of dy by dx together. This 1 by x will come down as it is and y will get subtracted on the opposite side. So in the next step it is x dy by dx minus 1 by y dy by dx is equal to 1 by x minus y. Now I will take out this dy by dx common from both the terms. So when I get dy by dx common, I get inside my bracket x minus 1 by y is equal to 1 by x minus y. Now obviously on both the sides what we will do is we will be taking LCM. Dy by dx xy minus 1 upon y one minus xy upon x. Cross multiply this on the opposite side, so you will get dy by dx is equal to 1 minus xy into y and xy minus 1 multiplied by x. Now if I compare both the bracket terms, actually they both are same. There is only a difference of sign. So in order to simplify that, what I do is I take out minus common over here, so that it looks like xy minus 1 into y upon xy minus 1 into x. We cancel off the value xy minus 1 and hence I get my final answer dy by dx is equal to minus y upon x. So yes guys, that is our value for the sum number 3. Okay, let us go to our question number 3, which is based on proving of the questions. So let us see question number 3. Okay, the question is x raised to 5 into y raised to 7 is equal to x plus y whole raised to 12. Prove that dy by dx is equal to y by x. I'm sorry, it is y raised to 7. Yeah. Now, when I want to simplify this, see guys, there are various methods to solve this particular question, but I would suggest applying log on both sides in this particular sum will be really helpful and will be making your work really simple. So if I say taking log on both the sides, I get is equal to log of x plus y to the power 12. Now property of log says if the terms are multiplied inside the log, we can apply log to both the terms separately and just add them. So I get log of x raised to 5 plus log of y raised to 7. And here it just comes down as it is, x plus y whole power 12. Now once again with the help of property, this 5 will go behind the first log, 7 behind the third log and 12 behind the last. So I get therefore 5 log x plus 7 log y is equal to 12 log x plus y. Now no further simplification is possible guys. So now I will say over here differentiating with respect to x. So when we differentiate the first element 5 log x, so it is 5 into 1 by x. Second element 7 log y, so it is 7 into 1 upon y. But we consider y as fx, so we have to multiply by the derivative of fx. So it is multiplied by dy by dx. And the last element, it is 12, which is the coefficient, and 1 upon x plus y multiplied by derivative of x plus y. So guys, this 5 by x will remain as it is, 7 by y dy by dx will also remain as it is, and here it will become 12 upon x plus y inside the bracket, derivative of x is 1, derivative of y is dy by dx. Now you all know this 12 upon x plus y will be multiplied with the first term as well as with the second term. So I will get over here 5 upon x plus 7 upon y into dy by dx is equal to 12 upon x plus y plus 12 upon x plus y multiplied by dy by dx. Now what we do over here is we take this element on the opposite side with a minus sign, and this 5 upon x goes on the right hand side with the minus sign. We are doing it like this because I have to take the terms of dy by dx together. So over here, 7 upon y minus 12 upon x plus y upon x plus y will be as it is, minus 5 upon x. Now I take out the terms dy by dx common from these both terms, and in the bracket 7 by y minus 12 by x plus y is equal to 12 by x plus y. Now on both the sides we have to take LCM. So very carefully, because there are lots of signs involved, 7x plus 7y minus 12y upon y into x plus y, 12x minus 5x plus and minus is minus 5y upon x into bracket x plus y. Now what I can do over there is I can cancel off the x plus y element because it gets directly cancelled off, and in the numerator 7x remains as it is, 7y minus 12y becomes minus 5y, and here 12x minus 5x becomes 7x minus 5y divided by x. So guys, if you observe carefully, 7x minus 5y will also get cancelled off. Here it will be remaining 1 by x. So yes, when I cross multiply that y, we get our required value as y upon x. Hence proved. Let us see the sum number 2. Sum number 2 is log of x plus y is equal to log of xy plus a. So both the terms we will directly use the formula for log of fx, the answer for which is 1 upon fx into derivative of fx. So in order to find the derivative, we have to write, as you all know, differentiate with respect to x. So it is 1 upon x plus y into derivative of x plus y, and on the right side it is 1 upon xy into derivative of xy. Yeah. Now guys, one more thing that I would like to tell. in case if you don't want to apply the derivative directly, and if you feel like using the property of logarithm first and then you want to go for the derivative, still final answer will be exactly same. Derivative of a is equal to 0, so I get over here plus 0. Now with this being my question, I have to prove that my dy by dx over here is nothing but minus y square upon x square. So here 1 upon x plus y, derivative of x is 1 and derivative of y is dy by dx. This 1 by xy remains as it is, and here we will apply the multiplication rule. So y into derivative of x, which is 1, plus x into derivative of y, which is dy by dx. Now guys, what we have to do is this gets multiplied to all the terms, both the terms inside the bracket, as well as this also gets multiplied to both the terms inside the bracket. One upon x plus y plus 1 upon x plus y into dy by dx. On the right hand side, it is y upon xy plus x upon xy into dy by dx. Cancel off these y elements as well as cancel off the x elements. Next, what I do is I transfer this element of dy by dx on the left and this element on the right with a negative sign. So what I get over here is 1 upon x plus y minus 1 upon y one upon x minus 1 upon x plus y. So now I can take out dy by dx common from these both terms. So the answer is and this is equal to 1 by x minus 1 by x plus y. I'm sure guys you all can make out these all small points. Now what we will do over here is on the left hand side as well as on the right hand side, both the sides we will be taking LCM, but very carefully because there are lots of signs which are involved over here. So this dy by dx remains as it is. I get y minus x and minus y because plus and minus will become minus. Y multiplied by x plus y. On the right hand side it's really easy. It is just x plus y minus x divided by x multiplied by x plus y. Now guys, what I do over here is x plus y and x plus y will get cancelled off. In the numerator, minus y and plus y, it will go away. On the right hand side, minus x and plus x will go away. So what I am left out with over here is dy by dx minus x by y, and it is y by x. Just if you cross multiply this guys, you will get minus y square upon x square. So that is your required answer, students. So hence it's proved. Now let us see the last question of this question as well as of the exercise, which is sum number 3. E raised to x plus e raised to y is equal to e raised to x plus y. And from here we have to prove that dy by dx is equal to minus of e to the power y minus x. So when we find out the derivative, we have to write over here differentiate with respect to x. So I will get derivative of e raised to x as e raised to x. E raised to y is assumed to be e raised to fx as we did in the previous sums. So I will get e raised to y multiplied by derivative of y, and again e raised to x plus y is also taken as e raised to fx. So you will get the answer over here as e raised to x plus y into derivative of x plus y. So guys, e raised to x over here remains as it is, e raised to y dy by dx, e raised to x plus y, and in the bracket 1 plus dy by dx. Now on the left hand side, no more simplification is left. We copy down that once again. And on the right hand side, what I have to do is, this gets multiplied with 1 as well as with dy by dx. So I get e raised to x plus y plus e raised to x plus y into dy by dx. Now guys, we take this dy by dx element on the left hand side with a minus sign, e raised to x on the element again with a minus sign. So what we are left out over here with is something like this: e raised to y dy by dx minus e raised to x plus y dy by dx. Over here we leave this e raised to x plus y as it is, minus e to the power x. Now what we do is we take out dy by dx common from these both elements. So what are we left out with? E raised to y minus e raised to x plus y. Here I write e raised to x plus y minus e raised to x. Divide this on the opposite side. So e raised to x plus y minus e raised to x divided by e raised to y minus e raised to x plus y. Now what I do over here is, I am given that since e raised to x plus y is equal to e raised to x plus e raised to y, in the denominator as well as numerator we substitute this value. So when we substitute, the numerator becomes e raised to x plus e raised to y minus e raised to x. denominator, leave this e raised to y as it is. Be careful, with a bracket I will write over here e raised to x plus e raised to y. In the numerator, cancel off this e raised to x, but in the denominator, open the brackets first. So you get e raised to y upon e raised to y minus e raised to x minus e raised to y. So guys, over here also e raised to y will get cancelled off. Now we have studied the laws of indices, according to which a raised to n upon a raised to n can be written as a raised to m minus n. So guys, we are ready with our answer. The minus over here remains as it is. This becomes e raised to y minus x. So that is what was required over here. Can you check it out? Minus y e raised to y minus x. So that becomes your dy by dx. Hence proof. I am sure all the sums have been very clear to everybody. In case you have got any other doubt, please feel free to mail me on my email ID. Thank you.